The purpose of this video is basically to walk you through further examples on probabilistic or graphical model. I'm going to share my screen right now. Give me 1 second. Okay, so as you can see, so the focus today is walking you through some example on probabilistic or graphical models. Okay, so I started this in class, but um, I realized that I needed to make a video so that for you to be able to follow through. Okay, so I'm gonna go to this network example one. Just like the way I demonstrated in class, what if in a situation whereby you basically want to find the probability of B giving a complement. Okay. Now, if you look at the network, you're basically going to see that B depends on A. You can see the direction of the arrow. And of course, you are given these values. This is the probability of B giving A, 0.8. So when A is true and when A is false, so you have 0.3. So automatically here is referring to this guy. Okay, the one for false is basically the a complement. So this guy is going to be 0.3. Okay, if you want to find, well, what if I ask you to find the probability of B complement given A? Okay, of course. So the probability of B complement given A is not given here. Don't forget, this is not centered on B. Okay, so you're actually going to use the complementary law, so which is basically going to be the probability of B, okay, given A. So when you take a look at this, this is A, and this are the complement of each other, and this guy here, okay, is a 0.8. So it's going to be 1 minus 0.8, and that will give 0.2. Okay, so another question may be, what if you want to find the probability of B complement given A complement? Now, if you want to find the probability of B complement, of course, you're actually going to use a complementary law. Okay, we are, the complement of B given A complement. Okay, and in that situation, it's basically going to be 1 minus. So if you come back here, so that you're actually referring to 0.3. So 1 minus is 0.3, that will be 0.7. Okay, so I wanted to take note of that. Now, another question is, what if they ask you to find the probability of C? Okay, if you want to find the probability of C, don't forget, C actually, give me 1 second. Let me write that. Okay, so C actually here depends on A. So you're actually going to use total probability. Okay, so using total probability now, so which means you're basically going to have the probability of A, okay, C, plus the probability of A complement, okay, C. Okay, so you want to use a total probability. Okay, so now when you take a look at this guy, the probability of the joint, and don't forget, C is conditionally on A. So you're basically going to have the probability of C given A, okay, multiplied by probability of A, plus, you're going to do the same thing here. The probability of C, okay, given A complement, okay, multiplied by probability of A complement. Now, when you take a look at this now, probability of C given A, okay, true. Okay, that is 0.8. Okay, then the probability of A, of course, here is 0.4, right? Okay, plus the probability of C giving A complement, okay, that would be 0.3, right? Then the probability of A complement, since this is probability of A is 0.4, you're going to use complementary rule. So that guy is going to be 0.6. Okay, so when you do your maths very well, okay, you basically gonna have 0.5. Okay, you're gonna have 0.5 for that. Now you've obtained probability of C now. So what if you want to find the probability of A given C? Okay, so let me clear my whiteboard. Okay, so you want to find the probability of A, right? Maybe they say find the probability of A given C. Okay, so the probability of A given C is not part of the network. Don't forget, C, according to the network, it is C depend on A, not A depend on C. So we can use the idea of Bayes' rule here. So which is basically going to be the probability of, the joint of that, divided by probability of C. And in that situation, okay, this guy is basically going to be the probability of C, right? Given A, okay, multiply by probability of A and everything divided by the total probability of C, okay? Now, the probability of C given A, okay, 0.8, okay, then the probability of A is 0.4. So the probability of C, I computed that the other time to be 0.5. Okay, so if you solve that out, you're basically going to have 0.64. Okay, that's super easy, right? Okay, so what if you now want to find the probability of D given A? Okay, you want to find the probability, give me 1 second. You want to find the probability of D, okay, given A, okay? Don't forget, if you take a look at this, A depend on B and depend on D, but I basically want to find the probability of D given A. So if I want to find the probability of D given A, of course, I'm actually going to consider the probability of the joint, A comma D, right? Divided by the probability of A. And you know what? Between D and A, there exists B, right? So I'm actually going to rewrite the numerator as the probability of A, okay, comma B, okay, comma D, okay, plus the probability of A, okay, comma B complement, then D, everything divided by probability of A. Okay, so which is more or less I'm focusing on AD using the idea of a total probability. Okay, so if I actually want to do that now, so I shouldn't forget that D depend on B and A, right? So I can rewrite this guy as the probability of D, okay, given A, comma B, okay, right? So then multiply by probability of A comma B, okay? I'm actually going to do the same to this guy here. So what I'm just going to have the probability of D given A comma B complement, okay? Multiply by probability of A, comma B complement, and this divided by the probability of A. Okay, so if you take a look at this guy, okay, and if you use that same guy on that, so I'm basically going to have the probability of D, okay, given A is basically going to be, so this guy here, okay, I can rewrite it as the probability of B given A. So I'm going to have the probability of D given A, comma B, okay, the probability of B given A. Don't forget, so this is a denominator to this. I can write that as that. And this also going to serve as the denominator to this guy. So similarly, I'm actually going to have the probability of D given A, comma B complement, right? Then multiply by the probability of B complement given A. Okay, so now don't forget, in the network, D depend on B and A. Okay, so I can rewrite the whole of this guy. Okay, I can rewrite that as probability of D given D given B, right? Because D, the direct descendant of D is B. Okay, so I can rewrite the whole of this as using the law of D separation, then multiply by probability of B given A. Excuse me. Oh, so give me that. Then plus the probability of D given B complement, okay, multiply by probability of B complement given A. Okay, so when you take a look at this guy now, the probability of D given B, that is 0.8, right? The probability of B given A, that's another 0.8, right? Plus the probability of D given B complement, okay, DB given, that is when B is false, so that'll be 0.3. Then the probability of B complement, okay, given A. So when you take a look at this guy here, of course, it's going to be 1 minus 0.8, so which is going to be 0.2, right? So when you solve this guy now, the probability of D given A is eventually going to be 0.7. Okay, so take a look at that. So what if I ask you to like figure out what is the probability of B, comma C? Of course, I show the probability of that in class, B and C, you're actually going to see there's A in between them. So don't forget, if you really want to solve that, you're first going to consider A, comma B, C, or which is going to be a plus, right? Then A complements, right? B, comma C. Okay, so and you're basically going to follow the idea that I use in class. So like for instance, BC depending on A now. So the probability of B, C conditioning. Of course, when you condition BC on A, you're actually going to multiply by probability of A. Okay, so the probability of the joint BC on A. So you're going to do the same thing here. The probability of B, comma C conditioning on A complements. of course, you're basically going to multiply that probability by a complement. Now, when you take a look at this, when I have, give me 1 second. Let me look at my time. Okay, so when I actually have the probability of two events, the joint of two event conditioning on A, okay, I can rewrite that as the probability of B conditioning on A and the probability of C conditioning on A. Don't forget, the joint of that is conditioning on A. I can rewrite that as that. So I can also do the same thing here. So if I really want to rewrite the whole of that now, okay, so I'm actually going to write the probability of B comma C. Okay, so if I want to rewrite that for that, so which is this guy, I'm actually going to write the probability of B given A multiplied by probability of C given A. Then don't forget this guy, the probability of A, okay, plus I'm going to do the same, except that the A is going to be in complement. So B given A complement the probability of C given A complement, then multiply by probability of A complement. Now you can now come back here. Now, what is the probability of B given A? So that is 0.8. Okay, so what is the probability of C given A? Okay, that is 0.8. So what is the probability of A? That would be 0.4. Okay, so you're going to multiply all that plus what is the probability of B given A complement? That would be 0.3. So what is the probability of C given A complement? That would be 0.3. And what is the probability of A complement? That would be 0.6. Okay, so if you do your maths very well, it's 0.8 is 0.8 and 0.4, then it's 0.3 times 0.3 times 0.6. When you add them up, the probability of BC is basically going to be 0.31. Okay, so that is how to do that. Okay, so I'm going to actually, stop that now. Give me 1 second. Now go to the next question. Okay, now in question 2, you have two alarm system, alarm 1, alarm 2, and of course burglary. If you look at the the two network here, okay, the two network here, this alarm 1 and alarm 2 are independent, right? There's no connection between them, and the burglary depends on alarm 1 and alarm 2. But right here, we're basically going to say that alarm depends on burglary. Okay, so you actually, to safeguard your house, you recently installed two different alarm systems, which is alarm 1, alarm 2, by two reputable manufacturers that use completely different sensors for the alarm system. Which one of the two Bayesian network given below makes independent assumption that are not true? Okay, independent assumption that are not true. Explain all of your reason. Alarm. So now, the one that basically make that is actually the second one. So the second one here, is suggesting the fact that alarm 1 and alarm 2 are kind of independent, right? They are, alarm 1 and alarm 2 does not depend on anything. Does not depend on burglary. You understand what I mean? So, in this system, it is burglary that depends on them. Okay, so that is why we actually choose that as the answer. Okay, so The second question now says, consider the forced Bayesian network. Okay, considering this guy now, the forced Bayesian network, where the alarm 1 and alarm 2 actually depend on burglary. Okay, now, um, you know how many probability need to be specified for its conditional probability table. Okay, and how many probability will need to be given if the same joint probability distribution were specified in a joint probability table. Now we're working on the first one. Now, when you are working on the first one, you can actually, we're, on this one now, right? Okay. Now, on that very one, you can base your alarm giving burglary, because in the first one, alarm depends on burglary. Okay, in this first one, alarm 1 and alarm 2 is conditioning on burglary. Now, what are the possible, that we can actually figure out, putting into consideration the network? We can have the probability of burglary as a prior. We can have a situation where the probability of alarm 1 giving burglary. We can have the probability of alarm 1 giving a complement of burglary. Anytime you see this sign, I'm actually referring to the complement of burglary. I can have alarm 2 giving burglary. I can have alarm 2 giving the complement of burglary. Okay, so if you count them, we're only going to have 5 probabilities. But if you don't want to look at the structure, and you have 3 node, you have 3 variables, okay, 1, 2, 3, and each of them is categorical. They each have 2 levels. Of course, the possible way is going to be 2 raised to power 3 minus 1. Okay, the 2 is the levels, each of them, so that you have burglary or not, effect of burglary or not, alarm 1, or not, so that the alarm 1 go on or not, or alarm 2 go on. So because you have, now it means you got two levels each, and because there are 3 of them, so that's basically going to be 2 raised to power 3. So 2 raised to power 3 minus 1, so that would basically be 7. That's what you have here. Now, in the next question, it's asking you to consider the second Bayesian network. Okay, now in the second Bayesian network, we want to consider this guy here. We basically want to consider this. Okay, this is what we want to consider now. The second Bayesian network that is saying burglary depend on alarm 1 and alarm 2. Okay, that burglary, it means alarm 1 and alarm 2, they can actually stand on their own. They are not dependent on anything. Now, because of that, we can have a prior probability for each of that. And if we want to have it for burglary, we're basically going to have burglary giving, you get what I mean? So let's look at the question. Now we're going to be focusing on this guy now, okay, to answer the next question. Okay, so in that question, you are given the probability of alarm 1 is going to be 0.1. Alarm 2 is going to be 0.2. Don't forget, the one we are actually answering, the question we want to answer now, right? The alarm 1, alarm 2 that are starting, together, okay? There is no, this between them, okay? Now, if you take a look at what I have, here right now. So this is, if I call this one A1 to represent alarm 1 and call this guy A2 to represent alarm 2, and then I'm actually going to call burglary B, right? So this is the one we actually want to use. Now you've been given alarm 1 to be 0.1, alarm 2 to be that, and everything that you are giving here is a conditioner. Of course, the burglary condition. So number 1, burglary conditioning on the joint A1, A2, the burglary conditioning on alarm 1 and the complement of alarm 2, the burglary depending on the complement of alarm 1 and alarm 2, and the burglary conditioning on the complement of both. And the question now asks you to find what is the probability of alarm 2 given the burglary and alarm 1. Based on this, don't forget, I'm using this network, which is basically the second network. Okay, now, if I want to do that now, okay, now what I basically want to find, okay, what I want to find is this guy. Okay, we want to find the probability of alarm 2 giving burglary, comma, alarm 1. And if I want to, the formula for that is basically going to be equal to the joint, all of that, this, which is this guy, and this guy, divided by the probability of the condition. You remember the way we normally do that. So if I want to find the probability of A given B, or A given B, of course, it's basically going to be a joint of that, right? It's going to be a joint of that divided by probability of B. You know that, right? We're using that knowledge. Okay, so that is the reason. So finding this guy now, we're basically going to use this. Okay, don't forget, you're going to have the joint of all of that, alarm 1, alarm 2, burglary. That is going to be in your numerator. Then divided by the probability of this. You see that now? Now, which means now, I need to figure out the numerator, which is the joint of alarm 1, alarm 2, burglary. Okay, I need to figure out that particular joint. And I also need to figure out this guy, the burglary and alarm 1. Okay, now, because of that, now the numerator now, which is this guy, the numerator, which is the probability of all the joints, how will I get that? That is what I want to find here, right? I want to find the probability of alarm 1, comma, alarm 2, and burglary. And if I want to find this, you know what I'm going to do? I'm going to go back to the network. How the network is expressed. You remember in class when when I was walking you, when you want to find the probability of the joint from the network. Now, don't forget, in the network that we're using, the network is like this, where this is alarm 1, A1, and alarm 2, A2. They are starting separately, and they now, goes to, they serve as the parent to burglary. Let me call burglary B. Now, when you make use of the network now, okay, then with the network, I'm actually going to have probability of, so the probability of the joint of all the variables, right, will now be the probability of alarm 1, which is this guy that starts separately, alarm 2, which is this guy, and B giving A1 and A2, which is this guy. You see that? So what do you think I'm actually using? So what I'm actually using is the network. Okay. Now, using the network now, that is the formula. So all what I'm going to do, and don't forget, you've already been given the values of what is the probability of alarm 1. You've been given probability of alarm 2. And the probability of burglary given alarm 1 and alarm 2. So I'm going to show you now. You're going to see. You've already been given. You see that they gave you probability of alarm 1, the probability of alarm 2, and they even gave you the probability of burglary given alarm 1 and alarm 2. So what I'm just going to do is to just plug in 0.1 for alarm 1, 0.2 for that, and 0.8 for this, which you have been given. So with that, I'm actually 0.016 now is this probability, the probability of the joint. Don't forget, I got the probability of the joint, alarm 1, alarm 2, and the burglary directly from the network. I'm basically going to put into consideration the network for me to be able to figure that out. Now, which means this guy here is the numerator from what I basically want to get, the numerator. Okay. Now, the next thing now is I want to figure out the denominator, which is the probability of the burglary and alarm 1. Okay, so if I want to figure out the probability of burglary and alarm 1, which is this guy, right? Don't forget, I want to find the denominator here, right? Now, the probability of the burglary and alarm 1, then don't forget, that's a total probability, right? Now, the burglary and alarm 1, you're going to consider alarm 2 along the line and the complement of alarm 2. If you follow what we've been doing, right? Okay. Now, so that probability now of burglary, alarm 1 is this guy plus this guy. And don't forget, we've already obtained this guy, which is what we just find out, the joint, which is what we got here. Okay. Oh, give me 1 second. So when you take a look at this guy now, right, it is 0.016, okay, that we got using just this guy, okay, using the whole of this guy. Don't forget, when I'm using that, it means I'm finding this, right? And that gives me 0.016, which is the joint. So that is what I'm actually going to plug in here. You see that? Now, the next thing that I now want to do is, how can I figure out this guy? Right? The probability of alarm 1, the complement of alarm 2, okay, and the burglary. What am I going to do? And that says, if I really want to figure out that guy, like I want to figure out this guy, then that is what I'm actually want to do here. That is what I'm doing here. Okay. So the probability of alarm 1, the complement of alarm 2, and the burglary. Okay. Now, you know what I'm going to do? I will also, the same way that I use the structure, that network, right? I'm going to use the network the way it is, that network, the second network. Don't forget the second network. Okay. Alarm, the second network, the alarm 1 and the alarm 2, they are starting and they all have, they all projected, they go to burglary. So the same way that I want to find the probability of alarm 1, complement of alarm 2, and the burglary, I'm going to put into consideration the network. What I'm basically going to do now, I'm going to write probability of alarm 1, then alarm 2, but complement because I'm focusing on complement. Then multiply by the probability of burglary, giving alarm 1 and alarm 2 complement. So that's what you see here. Okay, so which means I'm basically, using the network, right? Okay, so of course, the alarm 1 is given, is 0.1 in the question. The probability of burglary, the probability of a complement of alarm 2 is 0.8 because the probability of alarm 2 is 0.2. The complement of that would be 1 minus 0.2, that would be 0.8. And of course, the last one, the probability of burglary given alarm 1, complement of alarm 2 is 0.7. Let me show you. You have been given that one. It is right here. You've been given. So then you got 0.056. Now you are set. It is 0.056 is what you're going to plug in here so that you will be able to get this guy. Now you've gotten this guy now. Okay. And at the same time, you've gotten this guy. Don't forget that guy, you get the 0.016. This guy, you get the 0.072. Then you're going to do the ratio of that to that. So that's what you're doing here. And this is going to be your final results. You see that? Don't forget, we use the network. Okay, so the next thing, I'm basically going to go to the next question now. Okay, so in the next question now, okay, I have a Bayesian network. F is having the flu and C is coughing, right? And of course, coughing is conditioning on having the flu. Okay, so don't forget, coughing is symptom, one of the symptoms of having flu as a disease. Okay, but let me tell you, it is not everybody who cough. Okay, that have flu, and it is not everybody who have flu that cough. Okay, so I just wanted to take note. So now take a look at this. They've conducted research on the patients in this hospital, and 10% actually have flu, which is 0.1, and the probability of coughing, given that you have flu, is 0.8, which means 80% of the time. And the probability that you cough, given that you have flu, is 0.3, so which means 30% of the time. People may not have flu and they cough. Maybe they have other diseases. You get what I mean? Okay, so you've been given this. But the question now is, write down the joint probability table specified by the Bayesian network, specified by this network. So which means if I want to put this guy in place, I need to put into consideration the network. Okay, I want you to take note of that. Now, in putting this guy in place now, the FRC, this guy is more or less like I want to find the probability of joints, F comma C. Okay, that's what they mean by that. Now, if I want to find the probability of joint comma C, so which means in a way, I'm basically going to be using the fact that C, according to the network, is conditioning on F, okay, multiply by the probability of that. Now, we're actually going to have 4 different scenarios in the joint. You know why we're going to have 4 different scenarios? Because we have 2 levels of F. We also have 2 levels of curve. And since this is depending on that, it's going to be 2 times 2. That will be 4 levels. Now, the 4 possible levels now is basically you're actually going to use a tree diagram. Okay, more or less like you have a coin, true or false, and you toss that twice, right? You're actually going to have true, 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 false, false, true, and false, false. Okay, now if I want to decide on true, true now, okay, the true, true is basically, going to be the first one. The probability of having a false or having a flu is a 0.1. Okay. In order not to confuse you, maybe I can write it for you this way. It's the same. I can decide to start with that and later write C given F is the same. Okay. So this guy now is the first one here, which is this guy. Okay. And C given F, right? The cough given that it is true that you have the flu is 0.8. So that is why you are multiplying that, and that will give you this. Okay. Another possibility is true and false. Okay. True here, you are still using 0.1, but false at this end. The false at this end is more or less trying to say you are actually finding the probability of C complement given F. Okay. The probability of C complement given F is going to be 1 minus the probability of C given F. Okay. And that's going to be 1 minus 0.8. So that's why you see this 0.2. Okay, you get that. Now you're going to go to false true. Of course, in the false true, you're actually going to consider the complement of this guy. What is the complement of 0.1? That would be 0.9. Okay. Now, the true, don't forget. So now, if you now want to consider the corresponding, for that, because don't forget, for false, you said you actually using the probability of F complement, right? If you're using the probability of F complement, okay, for the other one, you basically, okay, have to use the probability of C given F complement. Okay, and don't forget this guy is actually this 0.3. Do you see that? So that is what you have here, and that gives you that. Now the last one is going to be false false. Okay, you're working on false false. So the false false now you basically want to consider the probability of this complement. Okay, and false at this end, okay, so which means you know, when you take a look at this now, you know, the probability, you have the probability of C giving F complement. Okay, now you actually need to find the probability of C complements given F complements. So which is basically going to be 1 minus the probability of C, okay, given F complements. So which is going to be 1 minus 0 0.3. So that would be 0 0.7. Now that is how you set up that table. Okay, so the next thing you're basically going to do after setting up the table, they can ask you, okay, so that is done. Now another question I said, determine the probability for the following Bayesian network. Okay, right now you actually have F, depending on C. Now, and they said so that it specified the same joint probability. So they as the given one. So you're basically going to use here. Now you want to find the probability of C. The probability of C is going to be a total probability. You know, if you want to get the probability of C, right? Okay. Now, if you want to go by what you have here, you're actually going to consider this situation and this situation. On C, which means you want to consider when C is true. It doesn't matter, the F. You want to consider when C is true. So that's why you are adding that guy to have this guy here. And the moment you have this guy, you can now figure out the probability of F given C, which is going to be the probability of joint divided by that. And FC, okay, true. So you're going to be 0 0.08 divided by the total probability. That's why you have that. The same way, similarly, you can find the probability of F given C complement, which is also going to be the probability of the joint of F C complement divided by probability of C complement. And of course, if you take a look at this guy, where C is actually false. Okay. Now here, okay, you actually you want to consider, where C is actually false in the joint. So if you take a look at this, right, the probability of C, if at the moment you actually have probability of C here to be 0.35, the 1 minus that will give you the complement, so which is 0 0.65. And of course, the 1 here, you're going to look at the joint of F and the complement of C, which is basically, which is this guy here. That is where your C is false. You see that? And you get that. Okay, so that's super easy, right? That's super easy. Okay, I'm gonna go to the next question. Okay, so so this is the last page that I basically want to work with you. Okay, now if you take a look at this question, they ask you to investigate. It said construct the probability where X and Z are independent. Okay, if you want to consider a situation where S and Z are independent, of course, you basically want to establish the probability of the joint. Okay, is it equal to the product of the marginal? That's exactly what we want to figure out. Okay, if you're able to figure out the product of that, that has been established. So what I want us to do now is, can we first figure out, looking at the network, can I figure out what is the probability of X? Okay, according to the network, don't forget X is conditionally on Y. So which means I'm basically going to do a total probability. So which means if I want to get the probability of X, I need to get, what is the probability of X, comma Y, right? Plus the probability of X, comma the complement of Y. Don't forget the total probability. So if I want to rewrite this guy now, I'm actually going to do the probability, don't forget, according to the network, S is conditioning on Y. So I'm actually going to have the probability of S given Y, right? Don't forget, I'm going to multiply by probability of y. I'm actually going to do the same here. The probability of x, giving y bar, okay, multiply by probability of y bar. I think this is super easy. So what is the probability of s giving y? Okay, that's given, right? 0.5. I'm actually going to plug that in, right? What is the probability of y? That is the 0.5 too, right? Plus, what is the probability of s giving y bar? Okay, it's right here. The probability of s giving y bar is also 0.5, right? What is the probability of y bar? So if the probability of y is 0.5, the probability of y bar is also going to be 0.5. That's the complement of that. So when you multiply, your final answer for the probability of s is going to be 0.5. Now you're going to do the same thing to probability of y. Okay, of course, similarly, if you want to get the probability of, the probability of z, not y. My bad. So the probability of z, because the question is asking us to investigate whether x and z are independent. And the only way to show, if you're able to show the probability of the joint of the two events can be written as the product of the marginal, then that is verified. Now, we figure out the probability of S to be this. We also want to do the same to the probability of Z. And according to the network, Z is also conditioning on Y. So which means we're going to go by way of, Z, comma Y, right? Plus the probability of Z, comma, the complement of y. So we're going to do the same. So we're basically going to have z conditioning on y, okay, multiply by probability of y plus the probability of z conditioning on y bar multiply by the probability of y bar. So what is this? Z given y 0.5. The probability of y is given to be 0.5. So the probability of z given y bar also 0.5. And of course, the probability of y is 0.5. The complement of that is basically going to be 0.5. And my final result here is basically going to be 0.5. So which means, for this guy, I got 0.5. And for this guy, I also got 0.5. Okay, so which means the product of this guy will give me a 0.25. Now, the next thing that I actually now want to do is I want to see whether the probability of SZ is going to be the same as 0.25. Now, if I want to do that as the probability of SZ, of course, I know the probability, X and Z are independent given Y. So I'm actually going to consider a situation where I have X, Y, Z, okay, or plus, okay, the probability of X, comma, Y bar, and Z, okay? That is exactly what I'm actually going to consider. Now, according to the network now, if I want to write this guy, I'm actually going to start with what is the probability of Y, okay? The next thing now, according to the network, what I can see in the network is the probability of X given Y, right? So what can I see again? Probability of Z given Y, right? This now is according to the network. So plus, I'm also going to do the same here. So basically, I'm actually going to, it's going to be the probability of Y bar, right? The probability of X. giving y bar, okay, then the probability of z giving y bar. Don't forget, I'm using the network. So what is the probability of y? 0.5. Okay, this guy now. Okay, this guy, 0.5. Now, what is the probability of s giving y? That is given here. That's another 0.5. So don't forget I'm multiplying now. What is the probability of z giving y? 0.5 plus, what is the probability of y bar? 0.5. What is the probability of s giving y bar? You know, when you take a look at this guy here, right? It's also 0.5. Take a look at that. And what is the probability of z? Okay. What is the probability of z, you know, or given that? So I have a 0.5. Now, when you multiply all that and you add up, that should give you 0.25. So what have we done? The probability of xz is the same as the product. Therefore, x and y are independent. That is the way to prove that. Okay, so that is where I'm actually going to stop. This is the end of this material. Okay, I would advise that you watch the video. If there's any area you don't understand, please let me know. Okay, so make sure you stay safe and have a lovely day. So bye for now, everyone.